Let's watch MIT Integration B and see how MIT students integrate.
Hello everyone, welcome to the 42nd annual Integration B, MIT Integration B. It's the same as a spelling bee, except that when you're spelling words, you solve integrals. 3, 2, 1, integrate. For those of you.
Okay, here's the first problem. So the problem is integrate the maximum of sine and sine 2x functions on the interval from 0 to 2 pi. So just to give you the idea, let's draw the graph of function. So the graph of sine function is the following, and the graph of sine 2x will be something like this. Let's watch how students solve the problem. We can discuss the problem afterwards.
You in the audience or watching this from home, feel free to also attempt it, try the integral. Thirty seconds. Ten seconds. Time. Stop writing. Thank you. The answer to this integral is 5/2.
He's checking the answers.
It seems like no one got this integral. So this also means that no one lose any points. So maybe that's a consolation.
So no one solved the problem. Maybe it's very too difficult for 2 minutes problem. So you have to do a lot of computations. Now let's see the solution. To solve this problem, it's better to draw the graph and then identify the maximum function. So we have the graph of sine function and sine 2x. So this maximum, the maximum means that you are choosing, so we have to identify the intersection points, and then in each, so these 5 intersection points will divide the graph into 4 parts. So in each part you have to choose the one which is maximum. So you have to choose the graph which is above the other one. So in the first interval, sine 2x, the graph of sine 2x is above the sine x. So you'll be integrating in the first interval from 0 to pi/3 the function sine 2x, just sine 2x. So also it's very easy to find these 5 points. It's just like sine x equal to sine 2x equation, so you can guess the answers. For the second interval, it's sine x, so you would be integrating the sine x function, which is from pi/2 to pi. You would be integrating just sine x. In the third integral, you integrate again sine 2x, and in the last integral last interval you integrate sine x again. So that will be the answer to the problem. So each of these integrals separately, they are very simple integrals, the integral of sine 2x and sine x, but there are 4 of them, and the question is, can you handle 4 of these integrals in 2 minutes? Or also you have to write down the simplified the initial integral in this form. So if you integrate this, each of them is negative cosine 2x over 2 or negative cosine x, and just by plugging the boundaries you can get that the result of this function is 5 over 2.